Okay, welcome everybody. So we're going to do the Unit 4 test review on polynomial operations and exponents. So the first one we're going to do is a simple division of a polynomial and a monomial. So we're going to rewrite this because it has an exponent of -1 as a division of 6y to the fourth plus 12y cubed plus 3y squared all divided by 3y squared. Now, I would suggest you write this as 3 separate fractions so that you can reduce them individually. And let's see how we divide 6y to the fourth divided by 3y squared. We get 2y squared plus 4y. 3y squared divided by 3y squared gives me 1. And I have simplified this polynomial. Okay, moving on to number 2. 3a squared b squared is being multiplied to everything in this sum. So I'm going to distribute and multiply coefficients and variables here. So 3 times 5 is 15. A squared times a is a cubed. B squared times b is b cubed. Okay, that's my first term. Now, 3 times 2 gives me 6. A squared times no other a's is just a squared. And b squared times b squared gives me b to the fourth. Okay, moving on. If you feel that I'm going too fast, feel free to pause the video and rewatch it as need be. Okay, so we're going to divide 18 and 6. Those divide nicely. It gives me 3. Q to the 9th, divided by q to the 9th, simplify, reduce to 1. R to the 3rd, divided by r to the 10th, leaves me with 7. Okay, and s to the 7th power divided by s squared leaves me with 5. So my new simplified monomial gives me 3 times s to the 5th all over r to the 7th. Number 4, we're going to cube everything inside here first. Okay, we're cubing it. So that means I have to cube the 3, the x squared, and the y cubed. Well, that means I have to multiply their exponents. So this becomes 3 cubed, which I know is 3 times 3 times 3. Well, that's 27. X squared cubed is x squared times x squared times x squared, or x to the 6th. Y cubed cubed gives me y to the 9th. Okay, now I'm going to square everything inside here. Multiplying the exponents, that gives me 4 squared times x squared times y to the 8th. 4 squared is 16 times x squared times y to the 8th. So now what I can use is my commutative property of multiplication and multiply 27 times 16, multiply x to the 6th times x squared, and y to the 9th multiplied with y to the 8th. Okay, so 27 times 16 gives me 432, I believe. And x to the 6th times x squared gives me x to the 8th power. While 9 plus 8 will give me 17, so that's y to the 17th power. And that's it. So I'm going to divide number 5. Now, because I'm dividing by a polynomial, in this case a binomial, I'm going to use long division, or I can use synthetic, up to you. In this example, I'm going to use long division. So let's see what I get when I divide 2x squared plus 7x minus 4 by x plus 4. Okay, 2x squared divided by x is just 2x. 2x times x is 2x squared. So now I want to multiply 2x by 4 and get 8x. Going to subtract here. My first term cancels, very good. 7x minus 8x is a negative x, and negative x divided by x is a negative 1. Negative 1 times x is negative x. Negative 1 times 4 is negative 4. Oh, I have to bring down my 4. And when I subtract these, I get a remainder of 0. So, this quotient is 2x minus 1. Now, over here, number 6, I've got a binomial times a binomial, so I'm going to use my distributive property twice here. Okay, and if you remember FOIL, first terms are going to be multiplied. X times 3x is 3x squared. The outer terms, x times negative 4 is negative 4x. The inner terms, 6 times 3x is going to be 18x. And L is the last term, 6 times negative 4 is negative 24. I've got some like terms here that I want to combine, and that will give me 14x minus 24. Okay. Number 7. Okay, be careful. The wrong thing to do would be to distribute and think of it as a monomial squared. What you should do, okay, is actually rewrite it as 3x minus 1 times 3x minus 1 and do your distributive property, just like we did in the last one. Okay, so what you should end up with is 9x squared. Negative 3x and a negative 3x makes a negative 6x, and negative 1 times negative 1 is a positive 1. And I'm done. And number 8, since we did long division before, I'll use synthetic division this time. Remember, we're going to take the divisor and set it equal to 0 and solve. So x plus 4 is equal to 0. Subtract 4, and I get x is equal to negative 4. So this will be part of my setup here. I'm going to take the coefficients in front of all the terms. I've got an x cubed term, I've got an x squared term, a linear term, and a constant term here. I'm going to take their coefficients of 1, 8, 11, and negative 20. I'm going to reduce this. So I'm going to bring down the number 1. I'm going to multiply. Negative 4 times 1 is negative 4. Add them up, you get 4. Negative 4 times 4 is negative 16. Add them up, you get negative 5. Negative 5 times negative 4 gives me positive 20. Add them up, and I get remainder of 0. Very good. So now, because we divided by a factor of x, everything here is going to drop a degree. So it was cubic, now it is going to be quadratic. So this is 1x squared. My quadratic drops to a linear, so this is now 4x. And my linear term now turns to a constant, minus 5. So my quotient here becomes x squared plus 4x minus 5, with no remainder. Okay, moving on. We're going to try that one more time with synthetic division. Because I have a divisor of x plus 2, I'm going to set it equal to 0, and I know that my x will be negative 2. So negative 2 will be part of my setup. And I'm going to be, I need a placeholder here for the x squared term since there's nothing there. So we're going to use a coefficient of 0 for that one. We're going to go from the fourth term, cubed term, squared term, linear term, and constant term. So I'm going to use 1, that's my coefficient for the quartic term. 2 is the coefficient for the cubic. 0 is the coefficient for the x squared since I don't have one. Negative 2 is for the linear, and negative 4 for the constant. So I'm going to drop down the 1 and multiply, and then add. Negative 2 times 1 is negative 2. Add them up, I get 0. Negative 2 times 0 is 0. Okay, I get 0. Negative 2 times 0 is 0 again. Add them up, you get negative 2. Negative 2 times negative 2 is positive 4. Add them up, you get remainder of 0. Okay, now the fourth degree drops down to a cubic. My cubic turns to a quadratic, but because I have no quadratics, Okay, it's 0 quadratics here. I'm not going to count it. I also don't have any linear terms. I have 0 x's. But I am going to bring down my constant term. So this is just x cubed minus 2. Pretty simple. Okay, now, number 10, we're going to use our distributive property. Okay, first term multiplies to everything in the second set of parentheses, while the second term will multiply to everything in the set of second parentheses as well. So let's do the top. X times 2x squared gives me 2x cubed. X times 5x gives me 5x squared. And then x times negative 2 is negative 2x. 3 times 2x squared gives me 6x squared. 3 times 5x gives me 15x. And 3 times negative 2 is negative 6. I'm going to add them up. Combine my like terms. I get 2x cubed plus 11x squared plus 13x minus 6. Okay. And now number 11, we're going to distribute again. 6x times 6x is 36x squared. 6x times negative 2y is negative 12xy. 2y times 6x is positive 12xy's. Remember, I want to put it in alphabetical order. Okay, so it's not going to be yx, it's going to be xy. 2y times negative 2y is a negative 4y squared. Okay, my middle terms here simplify and reduce to 0, so I'm left with 36x squared minus 4y squared. Okay, and this is a little 2. Let me fix that. Okay, number 12. Let's do this one as, we'll do it as a long division, why not? We did 2 synthetic divisions already. So let's do another long division. So I do have a missing term. I'm missing a linear term in between the x squared and the constant. So I'm going to have to put a placeholder. I've got my x minus 2 is my divisor. And I've got 2x cubed minus 3x squared plus 0x's plus 5. Okay, so 2x cubed divided by x gives me 2x squared. That gives me 2x cubed when I multiply them. 2x squared times negative 2 is a negative 4x squared. I'm going to subtract. And I get the first term to cancel like I want. Negative 3x squared plus 4x squared gives me 1 positive x squared. Bring down the 0x and the 5. Okay, x squared divided by x is just positive x. And I get x times x is x squared. X times negative 2 is negative 2x. And we're going to subtract. First term cancels, and I get 0 minus a negative 2 is a positive 2x. Bring down the 5. 2x divided by x gives me 2. So 2 times x is 2x. 2 times negative 2 is a negative 4. Go ahead and subtract. And this time I do get a remainder of 9. So I have to remember to put my quotient, my result, 2x squared plus x plus 2. I have to remember to add on my remainder of 9 all over my divisor. Okay. Number 13 is just a simple combining like terms. So we're going to subtract everything here. So I need to distribute that negative. So I've got 2x cubed minus an x cubed, negative 3x squared, minus 2x, and I have 5 minus 6. When I add them all up, I get x cubed minus 3x squared minus 2x minus 1. Okay, and I'm going to combine like terms. I've got some like terms here. Let's see. Actually, I don't have any like terms with the cubes. So I have 4x cubed. I've got a 5x squared. I do have linear terms that I can combine. 8 minus 3 is a positive 5x. And 5 and 6 makes 11. So I get 4x cubed plus 5x squared plus 5x plus 11. Okay, we're down to the last few questions here. Okay, I've got to find the inverse of g, so I need to write this as y is equal to x squared minus 5. I reverse the x and the y, so this becomes x is equal to y squared minus 5, and I have to solve for y. So I add 5 to both sides, and I've got x plus 5 is equal to y squared. To get y by itself, I take the square root of both sides. And because I want it to be a function, I'm going to take the principal square root, and this gives me y is equal to the square root of x plus 5. Of course, I want to use my symmetric property and write it as y inverse is equal to the square root of x plus 5. Okay. Find the domain and range of g. Well, g is x squared minus 5, so let's take a look at its graph. So because it starts right over here at -5 for the range and goes to infinity, my range is going to be from -5 to infinity. So the range is from -5 to infinity. While the domain, since this is a quadratic function, it's going to be all real numbers. So I can write -infinity to infinity, I can write all real numbers, any of those work. Okay? Now I want to compose for the last one. I want to put f inside of g's function, so I'm going to take f and drop it inside of g's function. I have to remember to square it and then subtract 5. So I need to square it and then subtract 5, and 4x minus 5 goes inside. So we know how to multiply binomials now. So this becomes 4x minus 5 times 4x minus 5, and then subtract 5 at the end. So this gives me 16x squared minus 20x minus 20x plus 25, and then minus 5 at the end. I've got some like terms here. I've got some like terms here. So I'm left with 16x squared minus 40x plus 20. And that's it. Okay, so expect to have examples or questions just like this on your test for the free response, and expect about 10 to 15 multiple choice questions. Good luck.